Hello again from Digicool Things. As a follow-up to my previous video where I introduced the 8-bit LED thing, I thought a video might be the best way to also demonstrate kitset assembly and provide a few helpful assembly tips. First off, assembly really is quite straightforward. It just involves some simple through-hole soldering. Don't worry about the surface mount devices. The tiny microcontroller board is all pre-assembled, pre-programmed and pre-tested. Most people wouldn't want to try soldering surface mount devices anyway, as the microcontroller is a tiny 3mm square QFN package and the other components are 0402, very small and not the sort of thing that most people would want to even try to assemble. So the 8-bit LED thing kitset comprises of a fully assembled, programmed and tested microcontroller board, a 16-pin dual-in-line LED bar display, and a 20-pin round-pin gold-plated header strip. Therefore, each kitset comprises of just these three components. The reason I chose to offer the 8-bit LED thing in kitset form is twofold. Firstly, some enthusiasts might want to use the tiny microcontroller board for other project purposes, and therefore may not want to solder on the LED bar display. All microcontroller port pins are available at the microcontroller board solder pads. Secondly, as the 8-bit LED thing is targeted at fellow electronic enthusiasts, it's highly likely you may want to assemble it yourself. But just in case, I do offer the option of me assembling the kitset for you, for a small fee, if you prefer. Okay, with that explained, let's dive in. Apart from the kitset itself, you'll also need your soldering iron and side cutters. And I also recommend a breadboard and optionally a power supply and a current limiting resistor. If you're using a 5V or a 3.3V power supply, then perhaps a 220 ohm or 270 ohm resistor would be ideal. Note that the 8-bit LED thing is rated for 2.95 to 5V supply. Now, the suggestion of a power supply and current limiting resistor is to allow checking the LED bar display before you solder it onto the microcontroller board. Although this shouldn't be necessary, it is generally a good idea to double check and be safe rather than sorry. You see, if you were to inadvertently solder the LED bar graph display the wrong way around, or if you were to discover one of the LEDs wasn't working, desoldering the LED display would be challenging and possibly damaging to the microcontroller board. Okay, first off is to identify the orientation of the LED bar display. Unlike a dual-in-line packaged IC, which usually has a really obvious dimple or notch to indicate the pin 1 end of the IC, the LED bar graph just has a subtle bevel on one corner edge of the display. Here's how it looks close up. You can usually either feel the bevel with your finger, comparing to the feel of the other corner edges, or you might want to use a magnifier. Once you've located pin 1, you can insert the LED bar graph into your breadboard, and we want to jumper all of the pin 1 side to your ground rail, so all shorted together and connected to ground, with the pins on the other side of the display not connected. As you've probably guessed, this is because the pin 1 side of the LED bar display has the cathode ends of the 8 LEDs. The other side, pins 9 to 16, are the anode ends of the 8 LEDs. So let's get that done. First I'll jumper 8 rows to ground. Then, with pin 1 identified, which on this display is the same side as the part number. So I'll plug that into the breadboard with the pin 1 side now all connected to ground. With power applied, We then want to connect each of the LED anode pins, i.e. pins 9 to 16, one at a time through the current limiting resistor to your power rail. So I'll just bend this resistor. All going well, we should then see each LED illuminate. So I'll go from power, first pin 16, and we have LED on, 15, 14, 13, 12, 11, 10, and 9. If they don't illuminate, chances are you have misidentified pin 1 of the LED display, or you forgot to turn on your power supply. Assuming you have now successfully tested your LED bar graph display, and therefore are confident it is all working, and you have correctly identified pin 1, then you are ready for your 8-bit LED thing assembly. The first step is to solder in the LED bar graph. So let's unwrap the microcontroller board. You'll note the pin 1 identifier on the PCB, a little round dot next to the square pad. The LED bar graph essentially fits over the tiny microcontroller and other tiny SMD components, effectively hiding them from sight. I just emphasize this to make sure you don't assemble the board upside down. So there's my pin 1 and the pin 1 identifier on the board with the components facing up. You want to push it down so it's firmly in place. Okay, with the LED bar display firmly in place, let's get it soldered. Once soldered, we can then snip off the excess leads with the side cutters. Next, we want to cut an 8-pin, a 4-pin and a 3-pin length from the supplied 20-pin round pin header strip. This should leave you with a 5-pin strip, which is surplus. Now back to your breadboard. With power disconnected, as we're just using the breadboard to assist with assembly, first insert the long pins of the header strips into your breadboard. Like so. That edge is a bit rough, so I might actually snip off a new 3-pin one from my surplus 5 pins. See if I can do a better job. Yeah, that looks nicer. Right, long pins down. You should have the 8-pin strip and the 3 and 4-pin strips inserted with a 0.5-inch spacing between them to replicate the remaining edge holes on the microcontroller board. With the longer pin sides of the header strips inserted into the breadboard, you should now be able to just drop the microcontroller board with its LED display in place onto the pins. We are now ready to solder the pins in place, knowing that the pins are all held nicely straight by the breadboard. Okay, let's get the pins soldered. And with that done, we've completed assembly of our 8-bit LED thing kit set. Pretty easy. Lastly, for some LED lighting enjoyment and to check your assembly, I'd suggest first jumpering the M1 mode pin to ground, and also connect the corner ground pin, pin 9, to your ground rail, and the corner VDD pin, pin 16, to your 5V or 3.3V power. I've already got a couple of pins jumpered, so if I move the LED display across, we have pin 9 connected to ground and pin 16, which is VDD, connected to the power rail. So I'll just jumper M1 to ground. Then after a final check, as we should always do, you're ready to apply 5V or 3.3V power. All going well, you should be immediately rewarded with an LED scanner display. Well, hopefully that demonstrated how easy it is to assemble an 8-bit LED thing, and has hopefully also provided a couple of useful tips to ensure successful assembly first time. That's it. Thanks for watching.